Good afternoon. I hope you're having a good second day at DevOps. My name's James McGivern. I'm going to do a Tools and Action talk on Tests That Talk, or 10 simple rules for cleaner, maintainable tests. So just before we get started, it's always good to know what's already out there. So if you haven't read any of these books, I really recommend them. Effective Unit Testing, Clean Coder, Uncle Bob, obviously he's got his web resources and videos as well. For anyone that doesn't want to read, they can watch. Test-Driven Development by Kent Beck, classic in the genre. And then Specification by Example is some of the new work on BBD by Godko. So these are great books. First rule, distribute your efforts. Lovely XKCD slide here. This is how mathematicians view the rest of the sciences. And this is really kind of fundamental because you've all seen this before. This is the testing pyramid. Basically, what this is showing is the rough distribution in the number of tests at each level. So at the bottom, we've got loads of unit tests, one for every unit of code, and we've got less component tests because you don't need to test every single pathway through that code because you've done that in the unit test, and so on and so on and so on up the levels. And the reason why I say this is like the mathematicians is because mathematicians look at physicists and then we look at them and we say, look what you've done with our maths. You've taken our beautiful theorem and you've proved something else on top of it. And you've been able to do that because we've proved these underlying basic unit theorems. And it's the same idea with your tests. You want to be building at every level a higher level of abstraction. You don't want to be doing all and every happy path and unhappy path with your Selenium tests because it's slow, the UI is fragile, it requires a lot of maintenance. So you push as much of it down as you can into the unit tests. There's another thing as well. Because as you go up the stack, the tests become more and more coupled because they're pulling in more and more parts of your domain. It means they become more fragile, which means that if you change any one lower part of your application, the chances are you're going to have to start changing tests up the stack. The more tests you've got up the top of the stack, the more of those tests you're going to have to change. Unit tests, by their nature, test a single unit of code. So if you change that unit of code, the only tests that need to change really are those unit tests. So the smaller you have going up, the better. In terms of an economist, we're talking about risk-reward ratio of writing tests decreases as you go up the stack. It's a great way of explaining to your boss why you shouldn't spend ages writing a massive wealth of Selenium tests when you've already got loads of other tests in the layers below. Second rule, test code is as important as production code. Anyone that doesn't treat their test code with as much or more respect than the production code is never going to get the best out of their tests. They should be clean and maintainable. We'll get into a little bit more about what that means in a couple of slides. But the basic rules are that things should make sense, as in you shouldn't have variable names called A, B, C, and weird test names like test A, test C, test combination D. None of that. You should be able to read a test as if it was something in English. Test methods should do this, should do that. Tests should be efficient and effective. What I mean by this is that they should be efficient, as in they should run quickly, and they should be effective, as in they should test what you expect them to test. Thank you. So they should be effective and efficient, fast, and do what they expect them to do. They should be deterministic. That means that you should not rely on things like injecting a random number as an input, because at every iteration that you execute that test, that number will change, and what that test is doing will change. What you want is a test that does the same thing over and over again, because that way when it fails and then passes again, you know you've done something to fix it, and it's not just something that it's changed in your input that's caused it to correct. Don't live with dead code. So tests marked as ignored are fine for, maybe the duration of your task. If they go over a sprint boundary, you're probably doing something wrong. I understand that occasionally this isn't practical. What you should start doing then is adding your own annotations or comments linking to, say, your bug tracker system, where you're saying this is where this was logged for backlog work or why it hasn't been done. Don't leave masses of comments in the code because they will become stale and dead. Leave as short as comments as possible because then it's got more chance of being alive. Excellent, it is still working. Given when then is from the BDD mindset, but it's a great way to lay out your unit tests. We'll see this in a next bit of code, hopefully I'll demonstrate. But just put a comment when you start your test. Blank test, you put a comment, given, comment when, comment then, and it will help make your brain focus on what the test is actually going to be doing. Like I said, test name should be should something or other. So if you've got a test for, say, a list class, should be able to add an element, should be able to remove an element, should be able to check whether the list contains an element. A class is an object. The things it does are actions. Therefore, you are describing the actions that should happen. It should do this. If you find you're struggling to do that, you're probably trying to test slightly wrong. This last one is a bit of a personal thing. Not everyone agrees, but I find that if you're creating a bunch of objects for use in your test, say users, rather than calling them user 1, 2, 3, 4 as the variable names, try and stick with letters because the human brain is better at breaking down letter boundaries than it is at breaking down number word boundaries. And there are other little tricks like that that you can pick up and use to make your test more readable. Test one thing at a time is rule number 3. Don't try to assert everything just to focus on what you're trying to test. Otherwise, you'll end up with multiple failures from a single test, and then you'll have to crack out your debugger and step through and work out which one's causing the failure. Or if you're really lucky, then your assert will give you a bit more information about which assert is failing. But then you've still got 4 asserts in that method, and how many of the changes... It just gets too complicated. We don't need that complication in our lives. We're developers. Everything we should do should be as simple as possible. So, test one thing at a time. If you've got more than a couple of asserts in a test method, it's probably a code smell. Revisit it. So like I said, it makes tracing failures easier. So tracing failures is obviously an important part of unit tests, but we don't write tests to track regressions and things like that. We write tests to prove that things are working the way we expect. So a test failure means something's not working the way we expect. And the quicker we can zero in on that and fix it, the faster we can move on to some more work and adding more business value, which makes our managers happy. Avoid loops in your test. So back in maybe 3-4 years ago, maybe a little bit longer, before some of the test frameworks had come on with their parameterized or wherever the TestNG version is, you used to find that there'd be like some setup where it would create a list or an array of user objects, say, and then it would iterate through them, and in each iteration it would do some when-then kind of action. Try and avoid that, because at some point that's going to fail and you're going to have to work out at which loop iteration it failed at and then maybe break that out into a single test. Don't give yourself that complication to deal with then. Deal with it up front. Write simple tests. Promote reuse of code. That's one way of avoiding loops. The BDD style thing, again, I'm going to hammer on quite a bit about this, even though none of this is about BDD. BDD, I think, is a great way to keep in mind what you're trying to test. And more importantly, when you turn around to your manager and say, look, this test is failing, you can say, look, this test is saying, given these conditions, when this happens, then this should happen, and it's not, manager, I need to fix it. And he can go, great, I understand exactly what you need to do. Whereas if you go, oh, we've got an assertion failure in the user repository management service, and it's something to do with blah, 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 he's going to go, right, so how long is it going to take to fix? Should it's worth fixing? All these extra questions. So the BBD terminology gives you a great bridge to discussing these things with non-technical people or slightly less technical people. Just break out now. This is an example of what happens when you try and test everything at once. So we've got a predicate builder. It's you see these all the time in like Hibernate and those types of libraries. It actually doesn't work. This is just some dummy code just to give you an idea. And you can see here we've got one user repository, put some users in it, assert that it finds this user, Then we overwrite that variable with a new user repository, stick another user in, another test. And as you can see, this is just one test, and it's doing 3 or 4 different things. And debugging that, finding out what's going wrong, it's just too much work. Why do that? So why not consider splitting it up into something like this? One test, one assert. One test, one assert. Nice and simple. I know it sounds simple and it sounds obvious, but you would not believe the number of times I've come across people that have done those big monolithic kind of tests. They test everything possible. Sometimes they'll even do something, make an assert, and then do something else and make another assert. So they've actually got 2 chained tests in one method. And that's the kind of maintenance nightmare you could just do without. So, rule number 4, encapsulate your data object creation. Quite often, for example, you're working with Spring, you've got a repository or a DAO layer, and you want to insert some model objects into it, make sure it gets persisted to the data store. And so you'll have, some new user, username, password, and all the other details to go with it. But quite often in those cases, you only need to change a couple of the variables per object, or per instance of that user, say the first name and the surname, because it's just a test. You don't need fully developed user instances for the test. So what can you do? Well, you can write a method called createUser, pass in a username and a password, and it creates a whole new user object for you. And that's reusable throughout all those tests in that class. If you find it's reusable across more tests, you can extract it into its own class and make it a helper method. An alternative is DSLs and builder patterns. You saw a builder pattern there with the predicate builder. They require a bit more effort to implement in the first place. Quite often, it's more effort than unit tests will require. When it comes to component tests, integration tests, things like that, it becomes more and more feasible to use these DSLs, to invest the time into them. Don't mix test code with testing utility classes. Quite often, you'll see under, say, a Maven project, source/test/Java, there'll be so-and-so tests, so, test A test, B test, C test, and then list utility helper. Try and pull those out if you can. Don't litter up your test folder with code that's used in the tests but aren't tests. It just makes the structure of your project much harder to maintain. And it also makes it easier to reuse. If you pull it out into a separate module, separate jar that can be used by different projects, you never know when these things can be reused. The more you reuse them, the more you're leveraging people's work before you. And that's always a good thing. And of course, if you're making these utility classes, you have to test them too. And that's a great reason for pulling them into their own project, because then you've got the utility classes under source/main and all the tests for them under source/test. Whereas if you had tests for them in the same project, then you'd have under source/test, you'd have the test code for your project, the utilities for those tests, and then the tests for the utilities for those tests. Again, too much complication. Pull it all out, make it simple structure. And we can see an example of this from the Spring MVC. This is fairly new, Spring 3.1, I think it was, 3.2. They introduced this new integration testing framework, which uses this lovely builder pattern here, DSL. So mock MVC, perform get this URL, tell it that you're accepting JSON, and then you're saying, well, I expect that the state is going to be okay, the content's going to be this, and the JSON path is going to include some value that equates to Lee. Now, that, if you're going to implement it yourself, is a hell of a lot of work. But if you think about how many times you can reuse this across any Spring application, you can instantly see why the effort is worth the reward. You get nice, simple tests that are easy to read, easy to write, easy to run. And you get this massive reuse across all your tests in those projects. So, number 5. This is going to be a bit controversial. Mocking introduces fragility. Lots of people go on about how they love mocking, how it's a solution to so many of their woes. But an expectation on a mock is an implicit assumption of how the code you're mocking is going to behave. Let me give you an example. We have a new data structure type. If you try and get an object from it, it's indexed, and that index doesn't have an object there, it'll return a null. So we code up our mock to respond like that. And then down the line, we think, no, returning null is one of those big bad things that we decided should not be done. Don't return nulls from methods. So we need to do something else. We can either throw an exception or return a null object. If we return a null object, well, it's not so bad to alter the mock tests. But if we start throwing an exception, all those places where we've mocked this out, we should now be considering an exception that was never thrown before and now is thrown. And the mocks have no way of incorporating that data. So be careful when you're mocking, because it has this tight coupling between your code. Try and do it across the boundaries of your application only, not within the layer. So for example, do it passing the data from the service layer to the UI layer, or vice versa, or passing from the service layer to the data persistence layer. But don't do it inside the data persistence layer. Don't start mocking out other services in there if you can help it. It kind of breaks the unit test idea a bit, but at the same time, it removes that little bit of fragility that can be introduced by mocking. Mocking has its place, don't get me wrong. You should just be aware when you're using it that you are then taking control and saying, I expect this mock to do this because I expect the code it's representing to do this. And the moment those two things differ, your mock isn't actually then doing the right thing, and the test that's using it probably isn't testing the right thing. And that's obviously a really bad thing. Be aware. And the final point of mocks is that, yes, you can mock loads of stuff, and it's quite common to see at the end of a test, verify this method on this mock, verify this method on this mock. You're then testing the interaction between collaborators. Unit testing should really be about black box. It should be about the inputs and the outputs. Void methods obviously have a problem because they're depending on side effects. But anything that has a return value, that's how you should be testing it, not based on the interaction of the mocks inside. Void is that special case where you can use verifications. Anything else, you shouldn't be needing to use verifications. Rule number 6, don't rebuild the world if you just need to rebuild the house. So what do I mean by this? DB unit, for example. It's great. You can spin up a database, you can populate it, but that takes time. And if you're doing that for every method and every test, you're increasing the runtime of your tests. And what we want for you to test is quick, efficient, and effective, fast turnaround, good feedback for developers. So minimize your data sets if you can, and if you can't, then try and do some other things. Like Spring has this idea of dirtying the context. If the context gets dirty, then it will reload it. But if the context doesn't get dirtied, it doesn't. So you can introduce some of these ideas into your test. If the database gets modified, fine, ditch it. But if you're just reading data from it, don't, leave it. Use it as many times as you can. Isolate your tests as well. Another common problem I see is when it comes to tests that are using common objects. There's a static object at the top of the class, say a user, and it's trying to insert it into the database. If you then try and parallelize these tests, and it's using a single database instance, for example, you're suddenly going to end up with the same data being trying to enter repeated times, with clashes or rejected insert statements or inconsistent state in the database. So try and make sure that your tests are using different object data each. That way, when you parallelize them, they don't overlap and interfere with each other. And then you can get faster turnaround of your tests, and that's even better. Rule number 7, assert in English. Yeah, I know I'm speaking in Belgium. English is most of yours is second language. I appreciate that. So assert in French if you're French. There is assert that and Hamcrest and JUnit now. If you're still using assert true and assert false, you are so far behind the times. Wake up. It's dead easy. Assert that object, comma, is something. equal to something. There's a great list of semi-fluent method names you can use. Writing your own is easy as well for Hamcrest, but the generics are a pain. They got better in the more recent releases of Hamcrest, but they're still not perfect. Awaitility, if you've not heard of this, great little DSL for doing asynchronous tasks. So you can say, await until this variable has hit this value, or until this method has been called. Fantastic. Yoda time, ditch Java date time if you're still using that. If you're using the new Java 8 stuff, great. If you're still before that Yoda time, convert from the new date into the Yoda time, do your manipulation and convert back again. Don't beat yourself over the head with trying to do, date time calculations using Java's calendar still. Finally, AssertJ. AssertJ is a fairly new fairly new-ish test framework. And what we can see here is this is the predicate build we had earlier, where we had all the horrible multi-tests. And you can see that it's still got assert that is so-and-so. So this is the Hamcrest matching. Let's just have a quick look at the AssertJ matching. So what you can see here is that you can chain the assertion. So you've got a single assert that, and then we can say dot has size 2. Dot contains these as well. So instead of having several lines of asserts, you can wrap it up into one nice simple one. AssertJ has got utilities for Yoda time, for Neo4j, for a load of other libraries. So there's loads of extra already included rules that you can just start using. Okay, rule 8, categorize your tests. JUnit now has the wonderful categories annotation. It uses a class rather than a string to group your tests. So you can actually use class hierarchies to group your tests. So you can have all tests as the top one, and then unit tests and integration tests, subclasses of all tests, and label your tests with those. But you can also use fast test and slow test, feature set grouping. All of these things can be used. So feature set grouping, for example, if you're working on a feature, you don't want to run the entire unit test for the entire project every single time. Just run a subset of them for the feature test. Or if you're just doing quick checks that everything's still working, just run the quick test group. Or if you're just about to check in, run the all test group. It gives you so much more flexibility about how you run the tests and which tests are run so that you get the most feedback in the least amount of time. And as a developer, that's what you want. Number 9, go native. Encourage non- and semi-technical people to get involved in writing tests, even if it's just at the high levels. There are lots of BDD frameworks you can use. JBehave, Cucumber JVM, which is a replacement for the old nasty Cucumber Ruby port. This is a nice new clean Java version from the ground up. RAML, if you've not come across this, is a new one for specifying how REST APIs should work. Lambda-Behave, if you can, go see Richard Wilberton's talk on this time round. Lambda-Behave is a great way to test your code using Java 8. It's very native. None of this AssertJ stuff is needed. Or you can be the agent of change in your own company. Consider Spock. It's a Groovy testing framework, but it means you can leave your production code in Java and start writing your tests in Groovy. So there's no risk to the production code, but you gain a wealth of benefits from the slightly looser typing system that Groovy brings. It makes your tests easier to write. It makes them smaller. The closures are nice. All these little things make the test write in Groovy much nicer. And the final rule is have fun. It sounds perverse, but you're going to spend more time writing tests than you are writing code. And if you're not, then I would be worried about using your code. Sorry, but every line of code generally has 1 or 2 actions possible. Therefore, for every line of code, you're probably going to have 1 or 2 tests. Multiply that up, and you can see why you should have more test code than you have production code. So that's a rule of thumb. If you find yourself with an equal amount of test code to production code, you need more tests. Don't rely on coverage. Coverage just shows you which lines have been executed, not tested. So coverage is a good indicator, but it's not the be-all and end-all metric. Do not use it to show that you've got good testing of your application. So that's it. It's where the images are from. And we've got a few minutes left if anyone has any questions.
Do you have any advice for
Swing testing. It's been a while since I've done any swing testing. The last time I did it, I think, was with the swing robot. So I can't offer much more insight into swing testing than the swing robot API, which is, I think, quite old and not very reliable. No. Obviously, graphical user testing is one of the hardest things to do. Selenium makes that easy for web browsers. I don't know of anything equivalent to Selenium that works cross-platform for general UI testing, I'm afraid. No. Sorry. Yeah?
I have one issue with AssertJ chain. Doesn't that violate the rule of one assert per test? Because it seems not so.
It does, yes. It's one of those very careful things you have to decide. Are you asserting more than one thing, or are you asserting several things about the same change? So, for example, about inserting elements into a list and then checking that the list size is 2. That's okay. Putting elements into a list and then taking some out and having asserts in between those two operations, that's a definite no-no. So there's always going to be a balance between having more than one assert and not trying to assert more than one factual knowledge thing, and having multiple asserts that are actually just saying, yes, we know this state to be true. The list has 2 elements, and those 2 elements are this. Those 2 asserts are fine. But once you go beyond that, that's kind of when there is no hard and fast rule. It's always going to be, your best judgment. But your best judgment should be to try and reduce the number of asserts. So yeah, if you do get carried away with AssertJ, you can just get back to the same place you were with lots of lines of asserts. But it's a nicer API, so that's kind of why I recommend it. Cool. I can't see any more hands, so yeah.
When you skip mocking dependencies, when you instantiate them, do you still test them also at the lower level, or do you only create tests at the higher level?
So you mean, for example, where you've got a collaborator that you might not mock out because it's in the middle of a layer? Would you still mock that out or not? Is that the question?
You choose to instantiate it because of the arguments you just gave, but you can choose to only test it at the higher level, or both test it at the higher level, also in the original repo.
I understand, yes. So given that we're not going to mock this object, how should we test it? Should we allow another test to provide some coverage for that class, essentially, I guess is what you're asking? No. Every unit should be well tested. So the collaborator should have its own unit test that covers every single happy and unhappy path through it. What you'll generally find, though, is that when you're using that collaborator in your test won't need to go through every unhappy path in the collaborator. So you'll find that using that collaborator in a test, that test won't use every path in the collaborator. So you'll still need both sets of tests, but you won't need to, go through every possible conceivable output from that collaborator in your test. That obviously has the advantage that when you delete a unit of code, any tests that were incidentally covered by it or secondarily covered by it, obviously they would drop to 0 instantly. That's something we want to avoid. So having a unit test for every test, for every production code means that if you delete some tests, you're not risking upsetting, the coverage of those otherwise well-tested classes. You're suddenly just dumping all that well-tested data. Cool. We are out of time now, so thank you very much. Any more questions, please feel free to grab me outside, and enjoy the rest of DevOps.